Hi, it's Jo Karen Hudson. We're going to talk about the product and the quotient rule for radicals. Simplifying radicals. We'll factor the argument, that's what's underneath the radical. We'll look for perfect squares, pairs of like factors if taking a square root, perfect cubes, three like factors if we're taking a cube root. So we take the root of the perfect squares or cubes and leave the rest under the radical sign. So we want to simplify the following radicals. The square root of 50 is our first radical. Okay, I stopped the video and wrote the perfect squares and the perfect cubes over here so that I'd have them to move around and play with. You have your chart, but I can't point to the chart, so I wrote the chart up here. So we'll start with the square root of 50. So I'm looking for a perfect square that will divide evenly into 50, and I believe it would be 25. So I'll start with the square root of 25 times the square root of 2, because 25 times 2 is 50. Now, the square root of 25 will break down. Square root of 25 is 5, so now I'll have 5 square roots of 2, and that is my final answer. That's how we simplify radicals. Example 2, I'm looking at the square root of 81. So I see, let's see which one, that one's too big. 125 is too big, 64 is too big, 27 I believe will go into 81. So the cube root of 27 times the cube root of 3 is equal to the cube root of 81. But we know that the cube root of 27 is 3, so I have 3 cube roots of 3. Final answer there. So I have the square root of x to the 6th. Now, if there's not a little index there, it's understood to be a 2. So I'm going to divide my index into my exponent. 2 goes into 6 3 times, and there's not anything left over, so the square root of x to the 6th is x to the 3rd. 2 goes into 6 3 times, we will get x to the 3rd, and that makes sense because we know that x to the 3rd times x to the 3rd does give us x to the 6th. Okay, I picked up my chart and moved it down so that we could look at the perfect square. Oh, I picked up the wrong one. That'll be a good lesson for you. I picked up the wrong one. I need the chart for the cubes because this problem is a cube root. So I'm looking at the perfect cubes, and I'm looking for one that'll go into 40, and I see it. It would be 8. So we know that the cube root of 40 would be the cube root of 8 times the cube root of 5, and then I have the cube root of x to the 8th. The cube root of 8 is 2. The cube root of 5 won't break down, it has to stay, and I have to divide for the variable. 3 goes into 8 twice. 2 times 3 is 6. 2 left over, which means 3 goes into 8, which means x squared comes out, and I have the cube root of x squared left because there were 2 left over. So now let's figure out what the answer is. We need to put the outside parts together and then the inside parts together in the answer. So I'll have for the answer 2x squared cube root of 5x squared. Final answer there. Okay, I moved my cube root chart down here so that I could use it because this example 5 has a cube root in it. I'm looking for a perfect cube that will divide into 625, and I believe I see it. It's 125. The square root of 625 is the square root of 125. I'm sorry, the cube root of 125 times the cube root of 5. And the cube root of x cubed, well, 3 goes into 3 evenly one time with nothing left over. So the cube root of x cubed is just x. These two just cancel each other out. The cube root of 125 is 5, and the cube root of 5 will not break down. So I need to put my answer together. The outside parts are here. The inside part is here. So we'll have 5x cube roots of 5. The square root of 25, x to the 9th, y to the 16th. I know that the square root of 25 comes out even. The square root of x to the 9th and the square root of y to the 16th. Now these two come out even. The square root of 25 is 5. The square root of y to the 16th is y to the 8th. Let's write that down. The square root of 25 is 5. The square root, 2 goes into 16 8 times, so it will be y to the 8th. But I'm going to have to divide here. 2 goes into 9 4 times with 1 left over. So when I divide 2 into 9, I'll have x to the 4th coming out, and I'll have the square root of x staying. So this is the only part that's inside the radical. So I'll have 5x to the 4th, y to the 8th, square root of x. Final answer. The product rule says that we can multiply two radicals together as long as they have the same index. They have to be all square roots or they have to be all cube roots. The square root of x times the square root of y is the square root of x times y. So using that reasoning, we can say that the square root of 3 times the square root of 5 is the square root of 15. The cube root of 4 times the cube root of 7, they're both cube roots, would be the cube root of 28. Example 3, these are both square roots. The square root of n times the square root of 2 would be the square root of 2n. Final answer. Now in example 4, that is the cube root of 5 times the square root of 5, and we're not going to do problems where we multiply cube roots times square roots. They're a little bit too involved, so we're not going to simplify this one. Starting back, we have the square root of 10 times the square root of 18. If I multiply 10 times 18, I will get 180. Now, I want to pick up my chart. Okay, I'm looking for the perfect squares that will go into 180. Let's see, I believe it would be 36. The square root of 180 is the square root of 36 times the square root of 5, because 36 times 5 is 180. The square root of 36 turns into 6, so we have 6 square roots of 5. On example 6, when we multiply 3 square roots of 15 times 7 square roots of 10, we'll have to multiply the outside parts together and the inside parts together. 3 times 7 is 21, so we have 21 square roots of 150. I'm going to look back over here at my chart. I see the perfect square that will go into 150 is 25, so we have 21 times the square root of 25 times the square root of 6, because 25 times 6 is 150. So now I have 21. The square root of 25 is 5. Square root of 6. 21 times 5 is 105 square roots of 6. Final answer. Now, on this one, this is a cube root, and this is like a 1 in the front. So 1 times 7, when I multiply the outside parts, would be 7. And 18 times 9 is 162. So I have cube root of 162, and x squared times x to the 5th would be x to the 7th. Need my chart. Okay, I'm looking for the perfect cubes that will go into 162. I believe 27 times 6, 42, is 162. Yes, it is. Okay, so I will have 7, and then the cube root of 27 times the cube root of 6 times the cube root of x to the 7th. So now I'm going to simplify this. 7 times the cube root of 27 is 3. The cube root of 6 won't break down, but the cube root of x to the 7th, let's see, 3 goes into 7 twice. 3 times 2 is 6, so there's 1 left over, which means this turns into, 3 goes into 7 2 times, it turns into x squared cube root of x. There's 1 x left over. So 3 times 7 is 21. That takes care of that. Let's see, what else is on the outside? The x squared is on the outside right here, and what's left under the radical would be the 6x. Final answer there. The quotient rule. The quotient rule, we know that if we have the nth root of x over y, we can split the radical up and make it the nth root of x over the nth root of y. We can split it up, or if it's split up, we can put it back together, and this is a very helpful rule. So on this example 1, I'm going to split it up. I'm going to split this into the square root of 5 over the square root of 49. The square root of 5 won't break down, so I have negative the square root of 5 over the square root of 49 will break down. It's 7. The cube root of 27, if you think about the cubes, the cube root of 27 is a perfect cube, and 8 is a perfect cube. The cube root of 8 is 2, so that one was quite an easy problem. Example 3, the square root of 50 over the square root of 2, we can put this back together, and you see that 50 divides by 2. Put it all under one radical. 50 divides by 2, it gives me the square root of 25, and the square root of 25 is equal to 5. Looking at example 4, I see that 12 divided by 3 would be 4. I can actually put 35 divided by 5 back under one radical, and I will have 4 square roots of 7. 35 divided by 5 is 7. Negative the cube root of 125. 125 is a perfect cube. Cube root of 125 is 5. The cube root of y to the 9th, let's see, 3 goes into 9 3 times. 3 times 3 is 9. There's nothing left over. So the cube root of y to the 9th would be y to the 3rd. Now this one, let's see, 50 divides by 2. I'm going to put this back together and it'll be real easy. 50x cubed over 2x squared would give me the square root of 50 divided by 2 is 25, and x squared divided by, x cubed divided by x squared, when we subtract the exponents, we'll just have x. Square root of 25 times the square root of x. Square root of 25 is 5. The square root of x stays under the radical. It's a square root. You see, you cannot break that down because the exponent on this one is a 1, which is smaller than the 2, so it won't divide. So we get 5 square roots of x here. This is the last problem on this video. The volume of the cube is found to be, with this formula, v is equal to s cubed, where s is the length of one side of the cube. A vase has the shape of a cube, and it has a volume of 64 centimeters cubed. What is the depth of the cube? So we have s cubed is equal to 64. If we take the cube root of both sides, we'll have the cube root of 64 is equal to the cube root of s cubed. And you remember the cube root of 64, that's on our chart. That's a perfect cube. That's 4. And the cube root of s cubed, when these match, the radical just lifts off, is equal to s. Because 3 goes into 3 one time, it just lifts the radical off. So s is equal to 4 centimeters. 4 centimeters times 4 centimeters times 4 centimeters. 4 times 4 times 4 times 4 is 16 times 4 is 64. And centimeters times centimeters times centimeters, if you add the exponents, you'll have centimeters cubed. So it does check. This is Jo Karen Hudson speaking. Thank you and have a wonderful day.